Comparing graphs. In this video, you'll learn how to compare the features of graphs of functions and explain what they mean in the situations represented. You'll also learn how to make sense of an equation of the form f of x equals g of x and know how to find the solutions. So let's start by looking at features of graphs that we can compare. We can compare different features of graphs such as intercepts, rates of change, extremes, and intersections. Intercepts represent where the graph crosses the axes, and the rate of change represents how quickly the function increases or decreases. The maximum and minimum values represent the highest and lowest outputs of a function. And intersection points are where two functions have the same output. Let's start with an example where the graph shows the populations of Baltimore and Cleveland at different years. We can see that our x-axis represents the year and the y-axis represents the population. The solid blue line will show us Baltimore's population, and the dotted red line will show us Cleveland's population. So we're going to look at a few expressions and try to find the value. Our first expression says B of 1930. So we want to find the population of Baltimore in 1930. So we'll go to 1930 and go up until we hit our solid blue line. So we can see the population is around 800,000. The next one we're going to find is C of 1980. So we want to find the population in Cleveland in 1980. So we'll go to the year 1980 and go up until it hits our red dotted line. So now we can see the population is around 590,000. Next, we're going to compare the two populations of Baltimore and Cleveland in 1900. We'll start by looking at Baltimore's population in 1900, and we can see it's around 500,000. Now let's look at Cleveland's population in 1900. We can see this is right at 400,000. So we can say that in 1900, Baltimore had a greater population. Next, we're going to compare the populations again, but in 2000. We'll go to the year 2000 and go up to the blue line that represents Baltimore. So we can see that they had a population of 650,000. Now we'll look at the red line for Cleveland in 2000. And we can see they had a population of around 500,000. So in the year 2000, Baltimore had a greater population again over Cleveland. Now let's look at intersections. Intersections represent when two functions have the same output value. So we have an intersection here in the year 1910, and we see another intersection of both lines a little bit after 1940. So we can say that B of 1910 is equal to C of 1910. And we can also say that B of 1943 is equal to C of 1943. Here's another example. A of T is the average temperature of Aspen T months after the start of the year. M of T is the average temperature in Minneapolis T months after the start of the year. We want to know which city had a higher rate of change from January 1st to March 15th. Looking at the graph tells us that the x-axis represents the month and the y-axis represents the temperature. The solid blue line represents Aspen, and the dotted red line is for Minneapolis. So let's start by looking at the rate of change of Aspen. Since January 1st represents 1, we'll look to see what the y value is when x is 1. March 15th is in the middle of the month, so this will be represented when x is 3.5. Now we can find the rate of change by looking at the change in y values over the change in x values. So it looks like we went up 7 units and over 2.5 units. When we divide these, we get a rate of change of 2.8. Now let's look at the rate of change of Minneapolis. So we'll plot our dots on the red dotted line when x is 1 and x is 3.5. The rate of change is the change in y values over x values. And we can see that we went up 25 units, and we went over 2.5 again. Dividing these gives us an answer of 10. So we can see that this was a lot larger than Aspen's rate of change, so Minneapolis had the greater rate of change from January 1st to March 15th. Our next example gives us two graphs representing functions f and g. We're going to put up 3 statements and we'll decide if they're true or false. Our first statement says that f of 0 is greater than g of 0. Let's look at f of 0 first. When x is 0, the f line also shows a y value of 0. So we'll put 0 for this, and now we'll look at g of 0. If our input is 0 and we go up until we hit the red line, we see that that gives us a value of 14. Since 0 is not greater than 14, this is not a true statement. The next one says that there are two values of x where f of x is equal to g of x. So this tells us that we should see two intersections. We see one intersection here when x is negative 2, and then again when x is a little larger than 3. So this is a true statement. We were able to find the two intersections. Our last statement says that f of negative 3 is greater than g of 4. Let's start by finding f of negative 3. This gives us a value of 8 once we hit that black line. Now let's look at g of 4. When x is 4, we can see that it hits the red line of g at 6. So since 8 is greater than 6, this is a true statement. The last example gives us three graphs that represent the progress in 3 runners in a 400-meter race. We can see that the solid line represents runner A, the dotted line represents runner B, and the dashed line represents runner C. Now we're going to answer these 3 questions based on the graph that we're given. We want to know who ran at a constant rate, who stopped for a while, and who won. So let's start with who ran at a constant rate. A constant rate will show one straight line that doesn't change or switch directions. We can see that this dashed line doesn't change directions and it's constant the whole time. So this would be runner C. Now let's look to see who stopped for a while. If a runner stopped, it would show a horizontal line that doesn't increase or decrease. And we can see this straight line here on our solid line. So this would be runner A. Now let's decide who won. We know that the race was 400 meters long, so we need to determine who reached the distance of 400 the quickest. This point here shows us who hit the 400 mark first. It's a really close tie between runner B and C, but runner C, or the dashed line, hit that 400 mark first, so they were the winner. Now let's recap what we've learned. Key features of a graph help us compare graphs and understand how functions behave differently. And interpreting and comparing graphs in real-world context help us make sense of data and draw meaningful conclusions about trends, rates, and outcomes.